This is our sixth lesson in Chapter 0. This lesson is all about adding and subtracting fractions and mixed numbers. So this might be a lesson you want to watch a couple times because some students do struggle with this still in 7th grade. First vocab word, only vocab word, is mixed number. A mixed number is the combination of a whole number and a fraction. So it tells us that we have a whole number component and then a part of another whole right here. So our first example is 5 3/4. Another example would be -2 8/9. Our non-examples are 10 because it's a whole number, doesn't have a fraction piece. 2 4/10 because it's written as a decimal. Now if we switch this around and wrote it as a mixed number, then it would count. But as it is written, it doesn't count. And 1/3 is also a non-example because there are no whole number parts. Okay, so here are our notes for this lesson. First, we're going to line up the problem vertically. This is really, really important. In this lesson, I know that in the past you may have done some adding and subtracting horizontally with fractions, but in 7th grade we're going to do a lot more complex problems, and it makes more sense to line them up and down vertically. So let's make a conscious effort to do all of our addition and subtraction problems vertically. When we do them vertically, when we line them up like that, we're going to remember that common denominator is a must. Okay, if you don't remember how to find a common denominator, click back a couple videos. I think it's lesson number 2, and you can watch there are 2 methods to find common denominators. Okay, so let's get started. We have a quick review here. First kind of question for us, how do we change an improper fraction to a mixed number? This is not in your notes, so just pay attention. This is a really fast review. It's possible that some of our answers, especially when we are adding, could end up with an improper fraction. And that's not a complete final answer, so we do not want to leave it like that. So we want to talk about how to change a number like this, 18/4, where the numerator is bigger than the denominator. And we want to rewrite that as a mixed number. So the key to doing this job is to divide. But we do not divide into decimals here. A lot of students make that mistake. We want to divide and we want to get a remainder answer. Okay? So the 18 is going to drop into the house, and we need to figure out just how many times 4 goes into 18. That's going to tell us our whole number piece. Okay? So 4 goes into 18 4 whole times. We're going to draw that 4 nice and big in our quotient. 4 times 4 is 16. We're going to subtract. We get a remainder of 2, and then we stop. If you find yourself tempted to put a decimal right here, you're going into a decimal answer. That's not what we want. Fraction problems give us fraction answers, okay? So this is a really, really easy thing to do now. We just take our remainder, and that remainder becomes our numerator because it tells us that 4 goes into 18 4 whole times with 2 left over, and that's 2 of the fourths that we started with. So we bring our divisor up as the denominator there. Now hopefully you can see that that answer can be simplified. We can divide our numerator and denominator both by 2 because that's the GCF, and that gets us a final answer of 4 1/2. Okay, so that was just a quick review for us. If you want to do one more practice on your own, why don't you try doing 17/6 and changing that into a mixed number as well. Okay, so we have some examples here, and this time I decided to take the examples straight from your notes. I want some problems to be done properly in your notes so that you can do the rest of them. So here is our first example, 7 7/9 plus 4 5/6. Again, this is number 3 from your note packet, so do this along with me in your notes so that you have a perfect example. So the first thing we want to do is we want to have our problem written vertically. Okay, remember, we want to do this vertically as per our notes, and the reason for that is because it kind of sets it up into place values. Here's our fraction place value, here's our whole number place value, and it just makes sense because this is how we do addition in every other way. Okay, so I'm going to switch colors here. We need to find a common denominator for 9 and 6. You could use some of your common denominator methods. I know that that LCD is 18. So to get an 18 from a 9, we got to multiply by 2. If I do that to the denominator, I do the same thing to the numerator. To get an 18 from a 6, we have to multiply by 3, and then we multiply our numerator as well. Now, we want to rewrite the entire problem. We bring our whole number 7 over here. 7 times 2 is 14. 9 times 2 is 18. Bring our whole number 4 over here. 5 times 3 is 15. 6 times 3 is also 18. Okay, so now we can go ahead and add them together. Place value first. 14 eighteenths plus 15 eighteenths. Well, our common denominator is there, so I can bring that common denominator into my sum. 14 plus 15 is 29. Now we can do our whole numbers. 7 plus 4 is 11. Okay, again, we kind of warned you about this in the last part. We could end up with some improper fractions here. So when we do that, we want to set up a quick division problem. See how many times 18 goes into 29? It goes in once. 1 times 18 is 18, and we get a remainder of 11. So that 11 becomes my numerator. There's 11 of those 18ths left over. Okay? So one tiny last step we have to do here. We have to combine our whole number pieces. 11 is a whole number. 1 is a whole number. So 11 plus 1 is 12. And we can bring down that fraction part. 12 and 11 eighteenths. Okay, so there is one of your answers finished for you from our notes. There's one more I want to look at. It's a subtraction problem. This is number 4 from your notes. This is a special problem because we will see a little bit of borrowing here. It's very important for us to understand borrowing with mixed numbers. So our first step is to write everything vertically. 5 3/8 minus 2 1/2. Then we know we have to find a common denominator. Common denominator for 2 and 8 is 4. So that means, common denominator for 2 and 8 is 8. That means I'm going to multiply my 2 times 4 here. And then I'm going to multiply the 1 by 4 as well to keep it equivalent. Rewrite my problem. I get 5 3/8 minus 2 4/8. Now remember what we talked about just a second ago. We're going to be borrowing here. The reason we're going to be borrowing is because we cannot take 4 away from 3, right? We cannot take 4/8 from 3/8. We don't have enough. So borrowing with fractions, a lot of students make mistakes here. Let's talk about it. We're going to borrow from the whole number. We borrow 1 whole. That leaves us with 4 wholes left. And then we have to add a whole to our fraction piece. So adding a whole means we're going to add a fraction equivalent to 1, and we want to add it as a like fraction. So I'm going to get the same denominator here so we can add our fractions. And how many eighths does it take to make 1 whole? Well, it's 8/8, right? If we have a circle cut into 8 pieces, if we have the whole circle shaded, that means all 8 pieces are shaded. And that's the same as 1 whole. So we add, just take your denominator and create a whole fraction. And you can add that in there. 3/8 plus 8/8 is 11/8. And now we are ready to subtract, okay? 11/8 minus 4/8 is 7/8. 4 minus 2 is 2, and we are already in simplest form. Make sure you review that. Watch this video a couple times if you have to, because this is very, very important.